On here to dot product for cartesian vectors. Now time no. No. Okay, we're going to let vector A be AX and AY, and let vector B be BX and BY. Then from the definition, of the dot product, A dot B equals magnitude A, magnitude B. Let's say that. All right. I'm going to draw a little diagram here. Sorry. It's going to be very close today for some reason. I don't want. I'm going to draw a little diagram here just to see here. So we'll see how we're going to get this. So we're going to draw. Vector A is going to look like this. Vector B is going to look like this. Okay, the angle between them is going to be this. I'm going to call this over here, this distance C for some reason. And that would be the origin, technically, is where that would be
from. So, would it say specifically let A equal this or B equal this?
This will just be the proof for this. We're going to go through this directly here, okay? Then I'm also going to call a vector C, which is going to be, I'm going to add together, we're going to say from the diagram, vector C equals A minus B, A minus B. All right, now I'm going to ask you guys to try and stay with me here for this, okay? Because this is something that we need to make sure we're good, make sure we feel good about. If vector C is A minus B, in terms of components, what is the X component going to be? Chris, go ahead.
It's going to be AX minus BX, and then AY minus BY.
Very good.
Hold up, let us write this over.
Yep, I'm sorry, I'm too excited. Really, imagine taking a week off learning. Would your brain just be ready to...
No, my brain's still on my break mode. I'm not the right thing.
I was thinking about you on the website actually, Gail, as there was sun and there was snow. I thought it was going to be
Oh, I thought you said you were with me.
I said I was thinking about you.
What?
No, because there was no snow. I thought you'd be sad because there's stuff like that.
No.
Although my dad went cross-country skiing.
Oh, now I'm working.
So he's back from here.
No, the hill's dead. It's all soft.
Okay. We're going to use cosine law here. And I'm going to pick on someone that's not next in line, but he's going to be fading in the back row, trying to avoid eye contact. Can you recite from memory, please? What's cosine law, please? Try, please. You can do it.
C equals C squared equals.
Okay, well, I want to be I'm sorry for that. This is something you got to know, though, okay? So it's the official pressure. Does somebody please want to be brave and help him with cosine law? Go ahead.
C squared equals A squared equals B squared minus 2A.
Do you always have to write it like with the absolute?
This time I'm going to because we're not having any direction on these vectors. Okay. Now, I'm gonna erase one, I'm gonna change one little thing for you guys here. What's angle C in this case? Sorry? Theta, whoever said that, right on, okay? So I'm just gonna reorganize things. I'm just gonna move everything over, and I'm gonna say 2 magnitude A, magnitude B, cosine theta equals magnitude A squared plus magnitude B squared minus magnitude C squared. I'm going to take a step back here just to make sure we're okay with the algebra. Can someone explain what I did there? Uh-oh, nobody can. Tori, go ahead.
You moved the 2AB cos theta on the other stick to the far side and then brought the AB and
Okay. Now, it's time to blow your minds. Start to blow your minds. What does magnitude A, magnitude B cos theta equal? What is magnitude A, magnitude B cos theta?
The
Dot product, right? So I'm going to call this 2 times, well, that the mind isn't, times A dot B equals magnitude A squared plus magnitude B squared minus magnitude C squared. Now, I know you're saying, Mr. Sadler, that's fascinating, okay, but this isn't going to make my life a whole lot easier, and let me assure you it will. Okay, so you're okay with what I did there? Magnitude AB cos theta is the same as A dot B. All right, can I get a brave volunteer to be, sorry, I see you guys scribbling, I'm going too fast, I'm sorry. Okay, sorry, go ahead.
should be A dot B in brackets, or is it not like that?
It's fine like that, that's okay like that. You can put a bracket if you like, yes.
It's 'cause, like,
Okay,
it's-
and this is where I'm to continue on with Austin's point here, that's 2 A dot B. I just want plain old A dot B. How do I make that just plain old A dot B? Divide by 2. So I'm going to say A dot B, and this still isn't looking nice, but it will, let me assure you. Now, the magic is going to happen momentarily. Okay, ready? What's the magnitude of A going to be? Sorry, if we're going to go for the magnitude of A, back from our previous lesson here, how do you find the distance between, or the magnitude of a vector? Anyone recall? This is called a proof, guys. This is what you'll have to deal with in university. Anyone taking first year math is going to have to do proofs like this. Right? Yeah. Right on. Okay, so I'm just going to get rid of the left-hand side for right now. And this is going to be the square root of ax plus ay all squared. Okay, because it's the distance, again, I can just use ax plus ay. Remember, we did this on the board over here for those that weren't with us because the other endpoint is 0. It technically would be ax minus 0 squared plus, did I get that right? I didn't quite get that right. That's better. That's better. Is that better? That's better. And then the same thing.
So wait, this is like the right-hand side.
Yeah, it's just the right-hand side. The left-hand side we're going to leave, okay? For right now. And then the bottom, I'm going to go to the second board here. This one's going to be a little bit more complicated. Now hold on, just wait before you guys flip out here. Just hold on, don't start screaming yet. Just wait, just wait. Remember that C was equal to, I'm sorry. Remember that's what vector C was. Remember from the previous previous board. Remember that's what vector C was? Remember that? Right. Stay with me. It's going to be happy at the end, okay? I wouldn't put you through this to give you a headache. Sorry, Bailey. Okay, but this is actually going to make you happy at the end. Okay, because things are going to start to cancel very quickly. What's the square root of ax? Oh, sorry, I'll give you guys just that right. I'm too excited here. Algebra proofs this will make you happy at the end, I swear. Can somebody please cancel here for me? What cancels? What cancels all the way through?
The square roots and
All the square roots and the square roots cancel. So I'm left with equals ax squared plus ay squared plus bx squared plus by squared minus, let's make sure I get the algebra right here. Okay, now you might say, Mr. Sadler, I don't see where this is going. I'm hoping to get things to cancel. That's what I'm hoping that's going to happen here. Okay, with any luck. So all I got rid of there, Bailey, and anyone else who is saying this isn't looking nice yet.
Yeah, no, I just finished the line before that. Now I look up there's a whole other line.
Well, we're just going to just square roots. That's all we did there, okay?
Yeah, the slow downs are actually listed in
Sorry,
what
Bill.
I'm saying.
Sorry, Bill. If you had to do this
No,
on your...
I had it in top and written, and then he's like, I look up and there's like a whole other thing. I'm like, oh, I ran out of room. So then I had to erase it.
It's okay, it happens, Bill. It's okay, it happens. All right. Any suggestion on what I should do next so I didn't cry? Go ahead, awesome.
Expand bracket.
Yeah, I'm going to expand this bracket right here. I'm going to expand this right here, 4 was out. Okay? So I'm going to change that to in green. This is all staying.
that cancels over.
Okay, now for those people saying, oh my goodness, I don't like algebra, I'm sorry you're in the wrong class. Okay, think back to the first thing. So hold on a sec. Caleb, don't cry. Was that you said what? Okay. All right. All I did there was I just squared, I just squared ax minus bx squared is ax squared minus 2ax bx plus bx squared. Then the same thing, ay minus by squared is ay squared minus 2ay by plus by squared. All right. Why am I happy at this moment? I can cancel so much stuff. I'm going to let everyone write this down first, so I don't get yelled at.
All of those are just two things.
So let's start canceling.
Probably not.
Let's start canceling. I have an ax squared, and I have a minus ax squared. Okay? I have an ay squared, I have a minus ay squared. I have a bx squared, and I have a minus bx squared. Well, this is a negative, it is. Then I have a by squared and a negative by squared. So this turns into okay, now, although you guys weren't feeling good about what just happened, look what that all canceled down to. What's that? All that means is you're just adding the components to multiplying the components together and adding them. That's all you're doing. So what I did there was I got rid of everything to do with an angle, which is nice. And remember I was saying, why is this going to be worse? Because with an angle you don't need to worry about it. Now, you may have to, I might give you a list of things to prove on your test, and this could be one of them, theoretically. Okay, so I'll give you a list of about 3 proofs, and I'll say if to prove one of them on your test, so this is fair game, this could be on there, okay? But I'll give you a list to make sure, okay? I won't make you study something randomly. Yes?
So you're gonna go through all the groups.
Yes. Like I'll be like, here's A, B, C, and I'll say you'll have to prove one of these on your test, right? So this is fair game, and this could be one of them to do, okay? All right, I hit pause and then when you do this. Now, although you may not be feeling good, like this is very cool, okay, what I've just done there. This makes the Cartesian version very, very easy to find the dot product of. I'm gonna hit pause on the video, then when I get going. Whoops, sorry. Sorry. What's going on?